In this video, I'm going to go over some basic math commands in Python. These I'm going to do in the terminal, but it doesn't matter what development environment you're using, the commands are still the same. The benefit of the terminal is if I type something in, it tells me the output as well, right here, which obviously if I type in 3 and I get 3, you know that, but if I want to show the output of some sort of mathematical operation like 1 plus 2, it'll still show me the output here without doing a print statement. So I'm just going to go over the different ways to do math in Python using the basic built-in math functions, and you can later learn how to display things. So we have our 4 basic operations that you're accustomed to: addition, subtraction, division, and multiplication. And the symbols for these are pretty straightforward. So for addition, we use plus. For subtraction, we use minus. So 2 minus 3 gives us -1. 4 minus 9 gives us -5. Division is just a slash. So if I do 9 divided by 4, it gives me the result of 2.25. If I do 10 divided by 3, we know that this would be 3.3 forever. But Python does tend to round to however many decimal places it's going to output for you. So you might get something, even though we know it's 3.3 going on forever, we might get something like this. And usually that's okay because rounding to however many decimal places out this is usually doesn't mess up your math too much. So we can mostly stick with this unless you're doing some more advanced application where you need things to be exact. And then multiplication is a star, so 6 times 2 gives us 12, for example. There are 2 others that are the built-in basic Python math functions, and these are a little more unusual. So you are used to the idea of exponents, maybe like 2 squared equals 4, because it's 2 times 2, 2 cubed equals 8, it's 2 times 2 times 2. If I want to represent 2 squared in Python, I actually use 2 stars to represent my exponent. So 2 squared is 4. Let's just move this back to the top of the screen. 2 to the 7th is 128, and that is the same as 2 times itself 7 times. 1, 2, 3, 4, 5, 6, 7. So you can see that this is indicating what we want an exponent to do, but it's an unusual way of writing it. Most people would naturally probably try something like 2 to the 7th. This is kind of more standard if you're used to doing this on a calculator or other things. But you'll notice that it doesn't really seem to know what to do with 2 to the 7th, and it gives us an output of 5, which isn't necessarily logical unless it's subtracting. But the point is, it's not going to give you the exponent, the expected output that you would hope to get if you're trying to do an exponent. Like that, 3 to the 8th. You can see I did 3 caret 8, and this seems to have added it, but this one seems to have subtracted it. So it's very important to be careful because it's not giving an error, but it is doing something bogus that's going to give you the wrong output in the end. So whenever you want an exponent, make sure you remember this double star thing. And then the last operation that we have that is also a little more unusual is the modulus. So I'll do a couple examples first, and then I'll explain a little more what's going on. 7% 2 is 7 mod 2. So the percent sign is the modulus. Here's the word. I have to put quotes around it just so it doesn't give me an error. So otherwise it might think it's a variable. So 7% 2, the percent sign is called the modulus. And if you read this, you would say 7 mod 2, or 8 mod 2 gives us 0. So what is going on here? Well, the modulus is the operation that gives you the remainder if you were to do the division. So for example, if we divided 7 by 2, 2 would go in 3 times, and then we would have a remainder of 1. So it would be 6 plus 1, giving us 7. So 1 is the remainder. And if I do 8 mod 2, Well, 2 goes into 8 4 times. There's no remainder. There's nothing left over. 2 times 4 is just 8. So the modulus is just 0. And this is actually a common trick in programming. If you want to know if a number is even or odd, you do mod 2. Because whenever you have an odd number like 13, well, that's 2 times 6, which is 12, with a remainder of 1. So whenever you have an odd number, the remainder is 1. And whenever you have an even number, the remainder is 0, because 2 goes into the even number an even number of times. So 2 times 10 is 20. But we can use it, of course, for more than just 2. I can do something like, let's do 100 mod 3. Before I hit enter, think about what's going to happen. 3 times 33 is 99. So 3 goes into 100 33 times. And then since 3 times 33 is 99, that means there's a remainder of 1 to bring us up to 100. So 100 mod 3 is 1. Maybe we'll do 17 mod 5, and let's try to predict what's going to happen. Well, I know 5 goes into 17 3 times, so 3 times 5 is 15, which means we would get a remainder of 2 in this division. So 17 mod 5 is 2 because we would have 15, which is a multiple of 5, plus 2 as our remainder. So we have 2. 10 mod 3 is going to be 1 because 3 goes into 10 3 times. We have 9. We have that 1 left over. And 10 mod 4, well, 4 goes into 10 twice. You have 4 times 2, which is 8. And then our remainder is 2. So 10 mod 4 is 2. This one takes a little longer to get used to. And it's going to give you the remainder in any situation. And sometimes, you're not necessarily going to be able to predict the remainder as easily. Like, I'm not going to figure out how many times 17 goes into 129,087, but this tells me that if I were to divide 129,087 by 17, my remainder would be 6. Whatever we get as a result of this mod operation is always our remainder. If I want to, say I were to flip this, that just gives us 17. In this first case, I'm asking the question of what happens if I divide 129,087 by 17, and it tells me, okay, it's going to go in a bunch of times and we'll get a remainder. Here I'm asking a question of how many times does 129,087 go into 17? Well, none. So the remainder, if the number over here is smaller, since this number just doesn't go in there at all, the remainder is just going to be the smaller number. So you'll notice in all the other examples I did, I put the larger number to the left, and then I could look at what the remainder is. But if I switch this and I do 3 mod 100, the computer's just like, well, 100 doesn't go into 3, so the remainder is just 3 because we haven't done anything. So whenever you have that smaller number first, whatever it is, that's just going to be the result of your mod operation. So be careful because a lot of times people do switch this and then they get the wrong result. And when you're just doing small things like this, it's not a big deal, but you will advance significantly in your programming throughout this class. And as you do, you want to be able to have a higher level of predictability about how these things are going to behave. So these are the basic operations. We can string them together. One thing to note is you've probably noticed that mostly I just didn't put a space between the operator and the numbers, but you can. It doesn't it doesn't change the result. And sometimes you'll want to put a space. There are some standards for when you do this. Generally, you want to put a space in when you feel like it's necessary for readability. That's not the official line on when to put spaces in Python, but it's a good general rule. So if I just want something to be, a little more spread out, a little more readable, like 6 plus 6 being 12, totally fine. It's not going to affect the outcome. We can string these operations together. You don't have to just do one per line. So for example, I could do 6 plus 6 minus 5 all in one line. It'll, of course, add 6 plus 6, which is 12, and then subtract 5. And you should remember, maybe you didn't use this acronym, but the order of operations. Again, putting it in quotes just so it doesn't give me an error. So if you recall, PEMDAS is an acronym that's often used to indicate the order of operations in math, and it stands for parentheses, exponents, multiplication, division, addition, and subtraction. So this is the order that things are going to be executed in Python if you put multiple math statements in one line. So for example, if I do 5 plus 7 times 8, the first thing that's going to happen is 7 times 8 is going to happen before the addition because multiplication, the m, comes before a. So 7 times 8 will give us 56, and then 5 will be added, and we'll get 61. Now, this would be different if I did 5 plus 7 in parentheses and then times 8. Because, again, the order of operations says that we'll do parentheses first before anything else. So the first thing it will do is evaluate the parentheses, and it'll get 5 plus 7, which is 12, and then that result will be multiplied by 8. So we get 96 instead of 61. So when writing these statements, we have to be careful and just make sure we know the order of operations so we know how things are going to evaluate. A couple more tricks to go over. If you want to take a number and use it over and over, you can store it in a variable. So just like in algebra where you might have something like x equals 7, we can then treat x as 7 throughout our program. So we could do x times 2, and that's going to give us 14. So we're just going to do 7 times 2. It's just basically replacing it. So if I do something like x equals 7, I'm just assigning the value 7 to the variable x, and then it'll do 7 times 2 is 14. And I can use this as many times as I want in an expression. So if I want to do x to the x, that's the same as 7 to the 7, which is 7 times itself, 7 times. And we can see that x was treated just like that. So it is possible to use variables throughout, and sometimes this can be nice, especially if, if your number is something complicated, something that you want the option to change, or if you just want to store the result of an operation for doing something about it later. So like maybe right now I want to know like my exam average, and that is like 90 plus 60 plus 85 divided by 3. And I might want to store that in a variable. So if I type exam average, you can see it calculates that out. And I might want to store it in a variable so that later I can figure out my average for the whole class, and I can use the exam average as one of the factors in there. So storing things in a variable can just give you a way to store it to use later without having to retype an entire expression. And it also makes your code much more readable, because if you're looking at your code and you see exam underscore average, you obviously know what that's referring to, whereas if you just see an expression like this, you don't necessarily know what it is referring to. So we can also use variables, and they substitute just like the numbers. They get treated just as if you had straight up typed that number there. And like I said, you can use the same variable more than once. You can also use multiple variables. So I already have x equals 7. Maybe I'll do y equals 0 and z equals 9. And then I can do whatever I want with that. X plus x divided by y. Oh no, you can't do whatever you want because you can't divide by 0. Divided by z plus y. Okay, and then it'll give me a result, and again, the last digit is going to be rounded, so maybe this is just 1.5 going on forever, but this gives us enough precision, to have approximately the right result for most purposes. So those are your basics of math in Python. There are other math capabilities, but these are the most basic built-in ones. And there are 7 things really to remember. Addition is plus, subtraction is minus, division is slash, multiplication is a star, exponentiation is 2 stars, the percent sign means modulus, which is the remainder, and then the last thing to remember is PEMDAS, that the order of operations applies just as it does in your math class.